subscribe to our channel at Goodwill Groups of School.
Good afternoon, viewers. Hope you're having a nice time over there. This afternoon, we want to look at Pythagoras theorem. I am Mr. Opakweju Oluwafemi. Pythagoras theorem is an aspect of mathematics that carries along three sides of a right-angled triangle. We have those three sides are the hypotenuse, the opposite, and the adjacent side. And the theorem tells us that the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is, the hypotenuse square is equal to opposite square plus adjacent square. Now, let me give this picture to illustrate. We have our right angle triangle is there. It's a right angle triangle because of the angle 90 degrees. That is what makes it our right angle triangle. So now, by the time we move on, our right angle can be located, the diagram can be twisted in any way, but just watch the angle. Once you are able to identify that, okay, this is angle 90 degrees, that is our right angle triangle. The side that is directly facing. So we have the side that is facing that angle 90 degree directly as the hypotenuse. While the other two sides will come as our opposite and adjacent. We determine which one is which one based on the angle that is given alongside the right angle. If the angle is given at that point, that means the side that is facing that given angle, not angle 90 now, but another angle, a second angle, that side facing that angle will come as our opposite side, and the third side will now be the adjacent. And of course, you can see from here that the side that is the adjacent is the side that carries both the angle 90 and the other angle that is given. Now, Pythagoras theorem now tells us that our hypotenuse square is equal to the opposite square plus the adjacent square. So this is simply what Pythagoras theorem tells us. Now we'll be making use of this to solve some questions where we'll probably be given two sides and then we are asked to find the third one. It could be that we are given the opposite and the adjacent and then we're asked to find the hypotenuse, or we're given the hypotenuse and one of these two. Then we're asked to find the other one that is not given. So we take example 1 now. So this is the question. Given the length of the opposite and adjacent sides of a right angled triangle as 6 cm and 8 cm respectively, of what length is the hypotenuse? Now the solution. We have our right angle triangle is there like that. We are given two sides, the opposite and the adjacent. So let's take that angle as the other angle we are given Then this side is the opposite. The opposite is given to us as 6 centimeters. This is 6 cm. And then we have the adjacent is 8. So this is 8 centimeters. We are asked to find the hypotenuse here. So now from Pythagoras theorem, we are given that the square of the hypotenuse, that's h squared, is equal to opposite square plus adjacent square. So we have here the square of the hypotenuse is equal to opposite square, that is 6 squared in this case, plus adjacent square, that is 8 squared in this case. So this gives us the square of the hypotenuse is square of 6, that's 6 times 6, and that is 36. So this is 36. Square of 8, that is 8 times 8, and that gives us 64. Now, addition of the two values, 36 plus 64, should give us 100. So from here we have the hypotenuse, which is h, should be the square root of 100. And the square root of 100 is what? That is 10. The square root of 100 is 10. So the hypotenuse is 10 centimeters. Hypotenuse. This is the value we have for the hypotenuse. I hope this is clear to you. If you have any question, we can talk about it as we move on. We take another example. Alright, so now this is another question for us to take a look at. Given a right-angled triangle with hypotenuse 13 centimeter long and the opposite side 12 centimeter long, calculate the length of the adjacent side. And I want to believe this will be a very simple question if you have followed what we've done earlier carefully. Now, we have our right angled triangle is there, or just say we are given the hypotenuse is 13 centimeters, and then we are given the opposite side is 12 centimeters. We are asked to find the adjacent. Now, from Pythagoras theorem, we know that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. That is Pythagoras theorem. Hypotenuse we are given is 13 in this place, and that is equal to the opposite, which is 12, and then we have to find the adjacent. Now from here we have the adjacent square is equal to this, that's 13 squared minus 12 squared. That is, we've taken the like terms to be together now, and then the unknown value is separate on its own. So from here we have our adjacent squared is equal to, now 13 squared, that's 13 times 13, and that gives us 169 minus 12 times 12, that is 144. So this gives us our adjacent square is equal to 169 minus 144, and that should give us what? I guess you are right, that should give us 25. Now from here we have to find the value of the adjacent by taking the square root of 25, and our adjacent comes out as 5 centimeters. That is the simple solution to this question, and I hope this is very clear. Probably there may be more explanation you want to ask for. You can drop the question at the YouTube channel, where this is the YouTube channel of the school. Now, we are moving further now to look at what we call the Pythagorean triples. Pythagorean triples, that connects directly with Pythagoras theorem that we have taken a look at here. Alright, now Pythagorean triples. Now, the word triples is very similar to the word triplet, and you know what a triplet means. A triplet is a set of 3 children giving birth to at the same time. That is a triplet. So when we talk about Pythagorean triples, we are making reference to a set of 3 numbers that go together and they obey Pythagoras theorem, which means that those 3 numbers will be in such a way that the square of 2 out of those 3 numbers, when added together, will give us the same value as the square of the third one. So the third one now is coming out as the hypotenuse. That's the longest side. So that will be the largest of the 3 numbers. If we find the square of that largest number, and then we now find the square of the other 2 numbers and we add their own squares together, the addition will give us exactly the same value as the square of the largest of those 3 numbers, and that means the 3 of them together like that are Pythagorean triples. They will always go together. So as a student, you should be able to at least identify at a glance some of these Pythagorean triples. An example is we have 3, 4, 5. We have 3, 4, 5. This is an example of Pythagorean triples. Why? The largest of these 3 is 5. These 3 numbers, the largest is 5. So if we take the square of 5, this will give us 25. Now, come to the remaining 2. We have 3. If we take the square of 3, this is giving us 9. And if you take the square of 4, this is giving us what? That's 16. Now, add these 2 together. 9 and 16 together added will give us 25, which is just exactly the same as the square of this one. So that means these 3 numbers are Pythagorean triples. So by working more and more with time, we'll get to be able to remember this within seconds, that yes, 3, 4, 5 are Pythagorean triples. Other example of Pythagorean triple, we can have 5, 12 and 13. 5, 12 and 13. This is another example of Pythagorean triple. Now, if we take the square of 13, this gives us 169. If we take the square of these 2 values, square of 5 is 25, and square of 12 is 144. Add 25 and 144 together, this is giving us 169. To show that these three values are Pythagorean triples. So we can be asked that if 3 and 4 forms a Pythagorean triple with another number, and they didn't tell you that number, but they now tell you, and 3 and 4 are the opposite and the adjacent sides, then what is the value of the third side, or the third value which represents the hypotenuse? Then it's just a question of applying Pythagoras theorem to this and finding the square root of this. We will get the third value. Now, another thing that you should carry along is that once we have this basic Pythagorean triples, it is possible for us to get many more out of this, and that is simply by multiplying the three numbers, each of them by a fixed value. For example, if you are multiplying 3, 4, 5 by 2, that means you are taking 3 multiplied by 2, that is 6, and you are taking 4 also multiplied by 2, that is what? 8, and you are taking 5 multiplied by 2, that is 10. So from here now, it means 6, 8, and 10 also forms a Pythagorean triple. Why? We generated this from the value we have up there. Now let's check. We have 10 is the largest of these three numbers. So if we take 10 raised to power 2, this is giving us 100. Now take 6 raised to power 2, this is 36. Take 8 raised to power 2, this is 64. Now let's add 36 and 64 together. This gives us 100, and the same as the square of 10. So that means 6, 8, 10 are Pythagorean triples. So if we multiply by 3, that is giving us 9, 12, and 15. So 9, 12, 15 are Pythagorean triple. The same thing is applicable to this. If we multiply by the same factor or number all through, here multiplying by 2 now should give us 10 and 24 and 26. So that means 10, 24, and 26 also forms Pythagorean triple for us. So I want to believe that you have really enjoyed this class, and one of the exercises I want you to work on is to find more of these Pythagorean triples and practice with all other aspects that we have discussed about. If peradventure you have any question, you can drop the question at the YouTube channel of the school, Goodwill Group of School. Thank you.
Please subscribe to our channel at Goodwill Groups of School, a bargain.